We have reached the first type of function that we will be dealing with in this topic over here. And the first function or type of function that we will be dealing with is a linear function. So what does linear mean? First of all, if we look at the definition of linear, linear would mean a straight line. So straight line, yes, you heard it correctly. That is what linear means. So what we are actually looking at are straight line functions. That you could also call it, I think some teachers also call it straight line functions, but we know it as linear functions. Now in functions, the last video that I made, I haven't really done graphing. I've actually introduced you to the input and output values. Like when you have to input a value into a function, then you get a certain output value. In this case, I'm going to introduce you to graphs, and linear function is now a graph that we are going to deal with. So let's start with our Cartesian plane. So with our Cartesian plane, the Cartesian plane consists of two axes. The y-axis, which is a vertical line, like this, and then the x-axis, which is a horizontal line. So it looks something like this. Okay, so that's our first step into drawing a function. Any type of function. Now, what do we do next? What we need to indicate next is our arrows. So we have an arrow here, arrow over here as well, and also an arrow over here. And what do these arrows mean? If you look at the definition, maybe you have it in your textbook, you can see this arrow. This arrow just means that it's continuous basically. And the continuous just means, and I'm just going to write it here shortened out, this arrow means that it continues all the way to a very, very small number or a very, very big number. In this case, we're going to look at what are the names of the axes, but in this case we can clearly see that this very, very small number is represented as negative infinity, and the big number is represented as positive infinity. And the same as it goes over here, right? We have all the way to negative infinity, and we have all the way to positive infinity. And that is what our big and small, well, infinity is not really a number if you were to look at its actual state. Infinity is just how we express like the biggest value possible, the smallest value possible. But we'll get into that detail a bit later into this. This is just an introduction on how we perceive linear functions. Okay, that was just extra information. Let me actually get to the real part of the Cartesian plane. Now, as you can see, since we've drawn our axes and our arrows, right, to indicate that they are continuous still, we need to indicate our axis, like what axis are we dealing with. So what we should know right now from our Cartesian plane is that the x-axis is the horizontal line and the y-axis is the vertical line in that case. Okay, the next thing we are going to realize is, where do we start? Like, obviously in our functions, you should know by now, in the Cartesian plane we have units. Let's say, for example, okay, let's start here, right? The first thing we need to recognize is this center over here. What does the center tell us? This center over here, I'm just going to try and indicate it here. This is what we call the origin. Or you can call it the origin point. But the origin consists of a coordinate. It's the exact center of the Cartesian plane. So the coordinates that we will write for the origin is going to be 0 and 0. And this over here is our coordinate. Our coordinate consists of two different variable coordinates, such as an x-coordinate and a y-coordinate. As you can see, this over here is a full coordinate set, right? We call it a coordinate set in this case. But what do they consist of? They consist of the first number being, in this specific order, the x-coordinate, and the second number being the y-coordinate. That is how we express the coordinate sets in this case. And as you can see, the origin point is right in the center of the Cartesian plane, where x is equal to 0 and y is also equal to 0. Now, let's actually get into the units over here. So I'm just gonna keep okay, let me just try and do it in a different color here, right? So let's just add our units, right? We know that the center over here, right? The center here is just going to be the coordinates of 0 and 0, right? So we need to keep moving. Think about our number line, right? I'm gonna quickly go down over here, right? I don't know what this is, but there, I'm gonna go down here. Let's do our number line, right? So right here, if you can remember from like primary school or something, and you can see also these continuous lines of these arrows indicate it just goes on to negative infinity over here on this side, or it goes on to positive infinity. Okay, but we're not looking at that right now. What we are looking at is the fact that in our number lines, normally the middle we would indicate this is the point where the value is 0. And then we would just go on to say over here that these following numbers over here, this one would be 1, and then this one will be 2. And if we were to work backwards, we would say that this one and this one over here, this one would be -1 as integers, because we were introduced to integers already, and this would be -2. So that is our number line. So let's plot that. That is exactly our x-axis over here. So we're going to write it like this, right? We're going to have, let's say this is going to be 1, 2, and this is 3. So let's say that this is going to be +1, this is +2, and this is +3. And we're going to do the same thing over here, but with the negative side. So it's 1, 2, 3. This is going to be -1, -2, and -3. Okay, now we've done that with the x-axis, right? But what about the y-axis? How do we indicate the y-axis in this case? Now let me show you a very, very hidden trick over here. What the y-axis is, okay, so in this case, right, this was actually the x-axis, as you can see, where this 0 point over here was the origin in that case of the x-axis, where x is equal to 0. But what if we were to add the y-axis? Essentially what we are doing in this case, note how I'm actually just drawing the Cartesian plane again, is we're going to add a different number line, but this time vertical. So some logic that we can think about over here is whenever it ascends, whenever it goes up, we would say that it's moving in the positive direction. So what we would say is that when it goes upwards, it's actually going to positive infinity. And when it goes downwards, it's going to negative infinity. So that's what we are saying about these arrows over here as well. These continuous arrows. So what we can say over here, now that we know that this point over here is 0, over there at the origin point, we can say that this next line over here and this next line over here, this one will be 1, right? And then this one will also be +2. And then if we would work here, this line over here and this line over here, this would be -1. I know it's very cramped over here, and this one will be -2. So that is basically our Cartesian plane. And note how this is now going to be our y-axis in this case. And you can see we got a similar shape over here. So if we were to do it like indication wise, we would do this 1, 2, and we have 3, and then this one would be 1, 2, 3. This would be -3, -2, and this would be -1. And where this one would be 1, +1, +2, and +3. So this is generally how we look at graphs in this case. Now that we've gone through that, how do we look at linear functions? Now, how do we actually plot functions? I'm just going to move on. I'm going to clear the Cartesian plane, and we're going to simply look at what a linear function is. It's come to my attention that I could do the linear functions now, but this video could be a separate video specifically for Cartesian planes. So what I want to rather do is the next video I'll go over the linear functions, but this video I actually want to show you how we can look at coordinates. For here we have this coordinate set, which consists of an x and a y coordinate over here. So you can see the x and the y coordinate here, right? Now, how do we look at these coordinates over here? I'm just going to clear some space over here so that we can actually see what these coordinates, which number are we going to take from the Cartesian plane, right? Let's take this number. Let's say we take number 2. And let's take another number on the y-axis. So we're going to take an x-coordinate and a y-coordinate. So let's take positive 3, right? So we're going to take 2 and 3. And in that case, if we take those two numbers, we can clearly see, we need to see the point where those two numbers meet up. So in this case, if we were to draw like a dotted line of the 2 going up and the dotted line of the 3 going to the right, we can clearly see that at this point over here, they meet up, right? So therefore, we can write this coordinate in the set of x and a y coordinate. We know that the x value is 2, and then the y value is just positive 3, right? So that is how we write our coordinates, basically. If we were to take a different coordinate set, let's say in the negative side, for example, if we were to take, let's say, negative 2 and negative 1, right? If we were to take those two numbers, we can now see that this negative 1 will go all the way such that it will meet up with negative 2 over here, right? And then this coordinate, this coordinate set, they all meet up. Where the x coordinate will be, let's write it down here, negative 1 is the x coordinate, and negative 2 is the y coordinate. And that is how we perceive coordinates, and that's how we write down coordinates. Now, what if we're just talking about a value on its own? So this is what I mean, basically. If we were to do the following, if we were to say, what is the coordinate of, let's say, 1 alone? What is the coordinate of the number 1 only? So then we are talking about this point over here, right? Because we can see, where did that thing go? There. Okay, so we can clearly see that we are not going to be talking about any of those. So we're not talking about any of the y-axis values. So we are just going to be talking about the x coordinate, which is 1, right? So if we were to just express this as a coordinate set, we would write it as 1. But what is going to be the y value? The y value is going to be... okay, first of all, let's just check. What is the y value that it is in line with? If you can remember that this point over here, right, was our origin. And our origin consisted of the coordinates 0 and 0. Therefore, wouldn't you agree with me if that the y coordinate at this point over here would actually be 0? Therefore, the coordinate is of y, x equals to 1 will be in line with the coordinate y equals to 0 over here. So that is what our coordinate looks like. What if we were to talk about the y-axis, any point on the y-axis? So let's not talk about 1 there. Now let's talk about the point on the y-axis. Now, let's say we take a random number. Let's say negative 2, right? Negative 2 over here, that's the point that we're going to take, right? We know that this over here, we don't know. Okay, right now we want to know what the x coordinate is, but we do know that the y coordinate is going to be negative 2 because we chose it now. Now, what would be the x coordinate? In this case, if you were to notice that it is in line with the origin point, where we know that the origin once again contains the coordinates 0 and 0, we know that the x coordinate will be 0 in line with the y is equal to negative 2, basically. You can clearly see from if ever we are working with only one value on the Cartesian plane, then we are just going to, if it's on the axis, like the x or y axis, we can clearly see that the corresponding axis is going to be 0. Like if we will work with the x value over here, then we would know that the y, if we were to work on the x-axis, then the y value will be equal to 0. And if we were to work on the y-axis, the x value will be 0. So that is how we represent the stuff over here. So I'm just going to fill it in over here. We can see that this x coordinate will be 0. And then we can write it like this, right? On the x-axis, we can write this as y is equal to 0 as well. This is what we call the y is equal to 0 line. And then the y-axis is what we call the x equals to 0 line. So to break it up for you, any point on the x-axis, any value on the x-axis, if you write its coordinate form, the y value will automatically be 0. And any point on the y-axis over here, we all know that the x value in the coordinate will then be equal to 0. And that is going to be very crucial information when we are dealing with intercepts. But that is going to be for a later stage. For this video, I just wanted to show you how do we look at coordinates, how do we write down coordinates, how do we visualize what the coordinates would look like, and how do we join them together like I showed you previously. And especially with our new lines that we should know by now, the x is equal to 0 line and the y is equal to 0 line that was also introduced. The next video I'll be going over linear functions as well.